Good day to all. Today we are going to see about single phase half controlled rectifier but separately excited DC motor. Previously we have seen about the single phase full control rectifier. The process is same as also here. We will just control the motor speed with the help of armature voltage. That armature voltage will have here input in AC, then we will have a half controlled rectifier DC. With that we will control this excited motor. For positive half cycle, we will have forward bias, reverse bias like this. See here, it's T1, T2, resistors and diode T1 and T2. Whereas in that full controlled rectifier, we will have the T1, T2, T3, T4. We will have thyristor like there. But here we will have a T1, T2 and D1, T2. D is nothing but the diode. Diode 1, diode 2. So the operation is same like this. T1 and D1 will be forward bias and D2 along with the T2 along with the this is the T2. T2 along with the D2 will be reverse biased. This is this T1 along with this. Here the positive voltage will come over here, then it will come over here, then it will come over here like this. The voltage will come. That time here it is negative, so this negative will flow like this. Then this one will have connected with the D2. Likewise, the flow will go. The current flow from Vs positive to T1 armature voltage, D1 Vs negative. Then here it is a freewheeling armature D1 and D1 to D2 armature, because see here, if it is in full wave control rectifier, if there is a less voltage than the source voltage, then it will have a reverse sign. But here the diode will take place to that particular circuit current flow. That is called freewheeling action. So the freewheeling action will take care with the armatures D1 and D2. Likewise, it will flow through. Then the negative off cycle. Negative off cycle is D2 and D2 will be forward bias. This D2 and D2. These two will be forward bias, and this T1 and D1 will be reverse bias. So the current, how the current will flow? The current will flow Vs positive here. The Vs positive is here, then negative will be here. Then current flow T2 armature and D2. D2 armature and D2. Then it will go here. Likewise, the reverse bias, the T1 will flow according to that way. This is the single phase half controlled rectifier sample. Then we will see the waveform as well as the equation of this particular half wave controlled rectifier. See here, this is the waveform of this single phase half wave controlled rectifier. Formula we have seen, VA voltage is equal to 1 by pi into alpha to pi. Whereas we will see there in the full control rectifier alpha to pi plus alpha. That is a full control rectifier. But here it is alpha to pi. Why? Because here there is a no waveform over here. there will be no value. So we didn't take about this one. For that we will take alpha to pi. So that alpha to pi Vm sin omega t into d omega t, which is equal to Vm by pi integral of alpha to pi sin omega t d omega t. So we will keep as this Vm by pi symbol here. Then we have minus cos omega t. If we are integrating sin omega t, that will come minus cos omega t. So we substitute pi into alpha. This pi and alpha upper and lower limit we will substitute in that omega t in that next step. So we have Vm by pi into minus of cos pi minus of cos alpha. Vm by pi minus of cos pi means cos pi value is minus 1 minus of cos alpha. So Va equal to Vm by pi into this minus into minus plus. So 1 plus this minus into minus plus cos alpha. So if we are varying this alpha, we will varying this voltage. That is the final equation of half-wave control rectifier. For that, pi alpha to pi value. See, this is the graph of that particular single phase half-wave rectifier. You can see here it is some slanting over here in that voltage waveform, and also here there is a no voltage somewhere here. This is the voltage waveform, and also you can see the current. It will come to 0 for certain time. That time there is a no current flow somewhere here. This is the voltage and the current waveform mixed with the sine waveform. For that we will have that equation. See, there are two limits, this pi to alpha to pi, and here there is a no power, no voltage in the circuit. Then there is a beta to pi alpha. So we will see that equation. Here this already we know, alpha to pi equal to sin omega t into d omega t. This p to pi alpha is nothing but the EMF equation. That the EMF energy will occur here. So we will take that E here, then we will do that equation. So we will see 1 by pi into Vm integral of alpha to pi sin omega t d omega t plus E into integral of beta into alpha plus pi plus alpha into d omega dt. We will take that E constant outside. So this will be come over here. Then Vm sin omega t integral is minus cos omega t. We will put here plus E into d omega dt. If you want to integral, then it will come omega dt with the limit of pi plus alpha into beta. So 1 by pi Vm of minus cos pi minus cos alpha plus E into pi plus alpha minus beta. Then it will come 1 by pi into Vm minus cos pi value is minus 1 minus of cos alpha plus E into pi plus alpha minus beta. So we will see again the Va equal to 1 by pi Vm into this minus into minus plus, so plus 1 into this minus into this minus plus, so plus cos alpha, this plus come over here, plus then E into alpha pi plus alpha minus beta. For the before equation, we will see this voltage is varied with that cos alpha, same like here. If we are changing this alpha as well as this term, we will get the change in the voltage. That's all. Thank you.